Welcome back to Hardware Unboxed. Today I'm going to be showing you a question and answer interview session that we filmed with AMD's David McAfee back in February when I was in Austin to learn all about Ryzen Mobile 4000. A lot of that information we put into a separate video that we published on the channel yesterday, so if you missed all of that, go back and check that video out. In this interview, we'll be going through all the lingering questions from the Ryzen 4000 interview sessions, from things like why AMD chose to use a monolithic die design compared to chiplets, the choice between Vega and Navi for the GPU, how AMD sees itself competing with Intel and Nvidia in the coming years, and the choice of power limits and TDPs, and a lot more. So I think it's a really interesting discussion, and if you want to jump into any of these specific things that we talked about, I'll put some timestamps in the description below for you. I'm just jumping on here before we get into it with a few things to note. While this was filmed around a month ago, none of the information has changed between now and then, other than we were supposed to have benchmark data for you at this point from real world systems, but that has been delayed by a few weeks. So we will have that information for you as soon as we can, but at this stage we're still under NDA on that. Also, we had a very short amount of time to film this interview at the end of a busy day of meetings and briefings, so the production values aren't as great as I'd have liked, particularly with the camera focus towards the end of the video, so apologies for that, but hopefully you can still enjoy some of David's interesting answers to questions about Ryzen Mobile 4000. So let's get into it. Welcome back to Hardware Unboxed. We're here today at the AMD campus in Austin. First time I've ever been to Austin. It's been pretty interesting times out here. We've learned a lot about the Ryzen Mobile 4000 series that's coming up, and while we are filming this interview currently in February, this will be going live in March after the NDA, so there might be a few things we'll talk about here that will change a little bit over time between now and then. But I should introduce my guest. Here we have David McAfee. Do you want to talk a little bit
Sure,
about your role
absolutely.
at AMD and what you're involved with?
Absolutely. I'm David McAfee. I lead the client product management team. So that means anything that's Ryzen Mobile, Ryzen Threadripper. I manage those products from creating the roadmap to getting them developed to getting those products launched. So I get the joy of seeing all these products come to market that we've been working on for such a long time.
Yeah, and how are you feeling now that Ryzen 4000, you've been able to talk about it and share all the info with us?
It's been fantastic. It's been fantastic. I know that this is a product that we've been looking forward to, honestly, for years. We started the process of building 4000 Ryzen Mobile about 3 years ago, 2017. Nope, that's actually 4 years ago. So 2017 is when we really started first in the planning phases of this product, and seeing it finally come to market, come to fruition is such a rewarding experience.
Yeah, it's been very exciting for us to see it as well, because it sounds like the first Ryzen product for mobile that will be extremely competitive and really getting to beat your competitors. And speaking of your competitors, I'm interested to hear about, with Ryzen 4000, you're launching at this time of the year, and it doesn't really align too well with Intel's launch cycle, which tends to be towards sort of the end of the year. Yep. How do you feel that your Ryzen 4000 products are going to be competing with next generation from Intel, such as Tiger Lake, which we're expecting towards the end of the year? We've seen throughout the rest of today, very impressive performance compared to Ice Lake, but I think you guys will also have to compete with Tiger Lake. So
sure. No, I think the way, so first off, to talk about product introductions, we've aligned our product cadence and our product introductions really to match the OEM notebook cycle as we're talking about mobile products. Most of our OEMs like to refresh their entire portfolio in the spring of every year. They launch those products in spring, they build them through the summer, and as it comes into the holiday of every year, that's where they're really, worked all the kinks out of the manufacturing process. They're rolling in high volume at that point in time. And so our strategy has been really to look at the way that the mobile market is moving and the natural momentum of that market, and align our product cadences to that. Our 4000 Ryzen Mobile product, it's got 8 cores, 16 threads of Zen 2 processing power. It's built on 7 nanometer. It drives a very high performance CPU and GPU experience. Honestly, when we compare it against what we see from the competition today in market, we feel very good about the positioning of that product. And honestly, as we look forward to where we think the competition will be in their next generation, we still feel very good about what Ryzen 4000 is going to bring to laptop systems coming to market this year.
Yeah, I think I'd tend to agree as well, considering if your performance numbers, and at this point we haven't been able to actually benchmark the systems ourselves, but it sounds like the performance is significantly higher than the competition now, which bodes well, I guess, for the future. I've got another question about the competition as well, because one thing we didn't see mentioned throughout today is sort of how you're handling an Intel product paired with, say, an Nvidia, one of the low-power discrete GPU options, like we've seen from the MX series, for example. How do you see, the competition in that space, and how OEMs have sort of, while you guys have had Ryzen Mobile with powerful discrete, integrated graphics, we've seen a lot of OEMs prefer the Intel plus Nvidia option. How do you see Ryzen Mobile 4000 competing with that solution?
I think that the world is kind of changing as we speak right now in terms of the way that discrete graphics is thought about. For years, the Radeon graphics that we've put into our APUs has been continuing to ratchet up a level of performance. And one of the things that we've certainly seen is there's kind of two bars that you have to clear. The first bar is it just has to be good enough graphics to drive an everyday usage notebook performance experience, and that's multiple desktops and using Office applications and web browsers and streaming video, and not really a heavy 3D workload. But that's the baseline. Everybody's got to clear that bar. And then the next step is really getting to the point where with an APU you can match the performance of what you would get from some of those MX style entry-level graphics configurations. And that's where we think we're really crossing over with 4000 series Ryzen Mobile. With what we've done to optimize the performance of that graphics engine in 7 nanometer, we're delivering a graphics experience that offers very, very playable frame rates on 1080p, low settings, esports titles. And we think that's really where those other products have been successful, is delivering that type of experience. So I expect that if you look at both how AMD has been investing in graphics, and honestly how the competition is as well with some of the products they're bringing to market with Ice Lake, I think that narrative is going to change, and it's starting to change already. And people will see that the power of the integrated graphics engine in some of these very powerful APUs that are coming to market is really more than enough for most everything that they want to do with their systems.
Okay, yeah, I think that's fair. And I guess considering we're speaking about graphics at the moment, one of the questions that we've seen primarily through all of our coverage of Ryzen 4000 so far has been, Vega versus Navi, and sort of the timing not quite aligning there to get RDNA into these products. How close were you to being able to execute RDNA in Ryzen 4000, or was it still quite a way away from that timeline, sort of aligning? Yeah,
it was something that we evaluated extensively, and there were really two factors. Timing is one. Timing is important, and making sure that it aligned with the overall development timeline for the product. But the other is power efficiency. And I think one of the things that's really important for people to understand about GPUs is, some GPU architectures scale out very well to a large discrete graphics unit and provide massive amounts of performance in very high TDP envelopes. But in order to be a great graphics engine to put into an APU, it's got to scale down into a power envelope that fits into 12 or 15 watts. And so, as we looked at the options that we had on the table, either adopting the Navi architecture and using that first generation of the RDNA architecture, or optimizing what we had already proven out as a very effective architecture for our mobile products, we found that the better answer was actually to use that Vega architecture, optimize it for 7 nanometer, and really get more out of that engine than we would have gotten by moving to the newer architecture at that point in time. So we think that the choices that we made there were really based on evaluating the data between those two architectures, and we think it's the right choice for what we did with 4000 series Ryzen Mobile.
Yeah, it's interesting. So you say that if you had chosen to go with RDNA, that perhaps you wouldn't have been able to achieve that efficiency.
It would have forced other decisions in the design that would have affected the outcome of the product and the definition of the product. I think really when you take a step back and look at it, the size of the GPU, the size of the core complex, and the design are all dictated by efficiency, area efficiency of how dense can that core complex be, how dense can that GPU be, and how much performance per square millimeter of silicon area can you squeeze out of either architecture. And in the case of evaluating our two options of Vega and Navi architectures for this particular design, we saw that at the point in time where we had to make the decision about moving forward with one architecture or the other, the optimized Vega architecture really was the right choice to allow us to bring that large 8-core CPU complex with still very powerful leadership graphics in an optimized Vega version to this generation.
Yeah, and I think it's important to know that this is an optimized version of Vega. It's not the same version of Vega that you're using for Ryzen 3000, for example. So
that's right.
What are the sort of specific changes that have been made to optimize Vega for this generation?
So I think it starts with if you look at the number of compute units between 3000 series Ryzen Mobile and 4000 series Ryzen Mobile, it's actually a smaller GPU. And one of the things that we were able to do with 7 nanometer is, with a smaller number of compute units, run it at a higher frequency, optimize the plumbing or the fabric within that GPU to really allow more throughput to flow through that graphics engine. At the end of the day, every APU is really constrained by how much bandwidth you can move through the GPU. That's memory bandwidth, that's fabric bandwidth in the chip moving data in and out of the GPU. And so shrinking that to a slightly smaller GPU, running it at higher frequency, and improving the throughput of that total connection from memory bandwidth all the way through GPU allowed us to get more performance per compute unit. So, the math that we talked about at CES was that going from 8 compute units to 11, flip that around, going from 11 compute units to 8 compute units, we're actually getting 59% more performance per compute unit versus the 3000 series Ryzen Mobile products, which is a huge advantage. And again, part of that 7 nanometer, but part of that is really design optimization in really optimizing the total pipeline from memory all the way through the GPU.
One of the other things I was really interested in is the marketing that we've seen from Intel over the years being massive. They've spent a lot of time especially advertising their mobile products. Do you see AMD ramping that up more for Ryzen 4000 series because you've got this really great flagship product now?
I think the answer to that is absolutely. If you look at AMD's marketing efforts, we've taken a totally different approach to how we market our products. We did a survey of really how the entire industry markets CPUs, motherboards, graphics cards, notebooks for that matter, to end consumers, and it's a very dark themed, RGB oriented type of message. And while that works great for gaming products, that doesn't necessarily resonate with somebody who, is walking into their local computer shop to pick out their notebook.
Yep.
Many of those consumers are not as technology aware as somebody who's a gaming enthusiast that reads reviews, reads articles, researches their purchase, and then makes the decision that they know is absolutely the right one. In many cases, somebody who's buying a notebook walks into that computer shop and really the only thing that they know is that my old computer that's 5 years old is slow. I need a new one. I do, A, B, and C. Tell me what I should buy. And so trying to speak to that customer a little bit more and approach them in a way that resonates more with how they use their product, their frustrations that they see with their product, whether that's around performance or battery life or freezing or whatever the case might be with that 5-year-old laptop that they're still using. That's really the way that we've transformed the way that we speak to consumers in the AMD marketing messages that you'll see from us this year. And then I think the other thing is really, our approach to marketing has historically and always been doing that through partners. So we will partner very closely with our OEMs as they go to market, because first and foremost, it is, when we bring a product to market, it's a Lenovo laptop, or it's an HP laptop, or it's an Asus gaming laptop. And we want to help make our partners successful and fit our marketing and our messages into the way that they want to market the product overall. So that'll continue to be a large part of what we do, but we'll do that cooperatively with our OEMs to continue to build momentum there.
So as part of that, providing the budget for OEMs to advertise, or just convincing them to use their own advertising budget for this, and are you speaking to the actual retailers themselves to sort of educate them? Because it seems like a lot of the time you go into a store, they don't know much about your AMD products compared to Intel because of the market situation.
No, I think the way that you have to think about marketing a notebook product is the entire value chain, end to end. It takes everything from, at the very front end, educating the OEM's engineering teams about the product, about the advantages of the product and why they should design an AMD system. Once that system gets designed, then it's about, the next step in the chain, educating the regional teams, educating the retailers or the commercial sales teams if it's a pro system. And then, continuing down that chain all the way to the point where it's in the hands of the consumer. So as I look at what AMD is doing this year, it is attacking all points along that chain, educating about AMD, putting a lot of effort and energy into training retail sales associates, making sure that, it's not just a select few that know about AMD, but that information is getting all the way down to the people that you would find when you walked into that store and said, my 5-year-old notebook isn't doing it for me anymore. I need to get a new one.
Okay. Do you also expect AMD to be fairly competitive with the actual pricing of the APUs that you sell to OEMs? We've seen already with that on the desktop side. Obviously, that pricing is visible to us because you can just go and buy the chip. You're expecting also to be very competitive there for your OEM pricing?
I think that the way that we approach pricing on the notebook side, it is fundamentally different than on the desktop side. We do not publish our prices for our notebook processors, and that tends to be more of a very hand-in-hand collaboration with our OEMs to determine the pricing of our different products. But what I would say is, I think some of the initial systems that you've started to see OEMs talk about, as you move from 3000 series to 4000 series, the price band that represents a Ryzen 7 system, for instance, or a Ryzen 5 system, or a Ryzen 3 system, I don't think those are going to change dramatically as you go from 3000 series to 4000 series. I think that what users will see from AMD systems or OEM systems powered by AMD 4000 series Ryzen mobile processors is a very compelling value for the performance and capability they're getting out of their device.
Yeah, I think we've already seen that today. We saw the Lenovo system that was announced, I think it was 850 or 849.
Right. 849 US is their target retail price. And so, that again, in a beautiful 14-inch notebook that is, the world's thinnest and lightest 8-core notebook on the planet for $849, that's a pretty compelling value for somebody who wants to go build that system.
Switching gears a bit now, I wanted to talk a little bit about the TDP configurations that you've got for Ryzen APUs. And firstly, I think a lot of the performance numbers that you showed today, am I right in saying those were primarily the 25-watt TDP configuration, or was it 15 watts?
It was 15 watts. Yeah, most everything that we talked about today was based around a 15-watt configuration. And really what I should say is when we talk about TDP in notebooks, one of the most important considerations is what we call SPL, or sustained power limit. And SPL is really, in an elevated ambient temperature environment, how is the thermal solution, or how much heat is the thermal solution designed to dissipate? So a 15-watt notebook would say, if you're in a room or outside in the sun, it's 35 degrees C ambient, that thermal solution would be designed to dissipate 15 watts of power and keep the skin temperature under the specified limits for the product. So as we look at our systems that we're working with customers on today, many customers design around that 15-watt power envelope. But that doesn't mean that for intermittent periods of time, the processor won't boost well above 15 watts. Yep. You've got intermittent boost states. You have technologies like skin temperature tracking and other things that we shared a lot of details here on today that allow us to really maximize performance in any given system for as long as we possibly can. So what we showed today was primarily 15 watt. As you scale from 15 watt to 25 watt, what you should expect to see is high single digit to low double digit improvement in very multi-thread heavy workloads, as well as graphics workloads. Those two parts of the compute engine of the APU are able to scale with more power very easily. Things like single thread workloads really don't scale significantly with power at all. But that multi-thread CPU performance, which really is a matter of how much frequency can you run the CPU and the GPU at for sustained periods of time, those are going to be the things that drive that performance uplift going from 15 to 25 watts.
So do you think that in general the 15-watt TDP is a more efficient point in terms of your sort of performance? Because if you're raising from 15 to 25 watts and you're getting sort of your high single-digit type, performance uplifts, does it make more sense for OEMs to, generally speaking, choose 15 watts for these parts?
It's I will say that every notebook platform is a little bit unique, and every OEM as they specify a platform and put it on their roadmap, it's this balance between performance, weight, thermal solution, system cost. All of those things are factored into the decisions that they make around what TDP am I targeting. So for instance, the Lenovo system you mentioned earlier, the Slim 7, that's designed around a 25 watt power envelope. It's an $849 system, and I believe it has a sub 17 millimeter Z height. So it shows you that even at 25 watts of power, it's possible to design a very thin, very sleek system. Now, if an OEM said, you know what, I want a system that is the lightest, 1.5 kilogram or 1 kilogram system, the lightest system that they could make, then they might go for a smaller battery. They might go for a 15 watt solution so that the thermal solution that's built into that device isn't as heavy, doesn't involve as much, copper and all of those things. And so it's not that one choice is better than the other. It's all about, how does that OEM want to target the system? And maybe more importantly, how do you as the buyer of that system, want it to be? Do you want something that you can effortlessly carry around all day long? Or do you want something that maybe is a little less portable but gives you maximum performance? Notebooks are very, very personalized devices that people use in very different ways. And so I think there's no wrong answer to that. It's just a matter of, how individuals kind of feel about their own product and how they use it day to day.
Do you also expect to see the higher power limits benefit your higher core count parts more? Would you say, for a Core i5, not a Core i5, Ryzen 5 or Ryzen 3 part on the, 6 cores, 4 cores, that we're not going to be seeing the same sort of performance advantages that you showed today in some of the presentations?
I think the reality is, if you, the more cores you have in the product, the more benefit you get out of raising the TDP. That's, it simply said, the amount of power allocation per core is just helped exponentially with the more cores that, or maybe geometrically, not exponentially, but is helped significantly by increasing that power envelope. Once you get down into a 4-core device, for instance, you're already relatively close to maximizing the amount of power that can be allocated to that core. And so really scaling up in core count helps widen that benefit or increase that benefit that you see by going up in power.
And we also see with Intel, they're offering their Y series currently that's really low powered. It's sort of around that 7 to 9 watt sort of, I think their current generation's around there. Mm-hmm. Are there any plans for AMD? I'm pretty sure you can't talk about future products, but has AMD explored sort of those lower power targets, or are you sticking to sort of your minimum 12 watts for now?
I think that as we've looked at the market and how the market has evolved, those products that sit below 12 watts really exist on the fringe of the notebook market. That's a very small volume segment of the overall notebook TAM. When we look at the 12 to 25 watt space, that represents probably 99% of the notebooks that get sold in the world today. And maybe to take that even a step further, if you look at some of the systems that you would consider the archetype of a uber thin, uber portable system like an HP Spectre or something like that, that's a product that's built around a 12 to 15 watt power envelope. So having that Y series package does not necessarily mean that it can't be an incredibly thin and incredibly lightweight design. Our focus certainly as we're bringing 4000 series Ryzen Mobile out is to focus on that 99% of the market. There may absolutely be a point in time where we move in a different direction and expand the scope of what we do. But we think for the time being, the right answer is really go after that 12 to 25 watt envelope, because that's really where the bulk of systems lie.
One thing I was really interested in is today you launched the 4900H product, and we saw that the clock speeds are slightly higher. You're offering 8 compute units instead of 7 for the GPU. Is binning going to be a really key component of these mobile parts? I think we've seen for the desktop parts, again, for example, you go from the 12 to 16 core desktop part, both of those have the same TDP, and you see that the power consumption is very similar. Right. Are we seeing something very similar on these mobile parts as well, where binning is really going to determine sort of the clocks that these chips run at, and by buying something like a 4900H, you're going to be getting a better binned chip than 4800H?
So to answer that, is binning important, and how are we thinking about how these products fit into the overall portfolio? I think that we think of the Ryzen 9 product as a part of the H family, very similarly to how we think about, say, the Ryzen 9 3950X in our desktop family. We want it to be the highest performing, the most capable product that we can possibly build, and we will take advantage of, every little gain in process technology that we can squeeze into that design. We'll take advantage of every little bit of frequency that we can squeeze into that design. And absolutely, binning plays a huge part in making sure that we're getting, really the best of the best that are able to run the fastest. What's interesting, and again, this kind of speaks to that balance between notebooks and desktops, is that in a desktop, it's a lot easier to take parts that go really fast, because in a lot of cases, those parts that go really fast also are leakier parts that just burn a little bit more power. In a notebook, you don't always have that flexibility to take a really fast but really leaky part and put it into a notebook system. And so our goal as we look at Ryzen 9 and as we try to bring that product to market is to find that optimal point, the highest performing products that are still going to give you great battery life and give you a great mobile experience with the product. And I think that's what you'll see when we reveal all of the Ryzen 9 specs a little bit later.
Okay, I think that's good to know. And something I was really, really interested in when we first saw these parts announced was the fact that you weren't using the Chiplet Plus IO die design.
Yeah.
I think a lot of people, including myself, were sort of expecting that. Not sure why I was expecting it, because Monolithic maybe makes more sense. Can you speak to what was sort of the design decision there as to choosing to go Monolithic compared to the design you've been using for
that's a very good
desktop
question.
and Threadripper?
Yeah, that's a good question. Because we have seen on desktop and Threadripper, the chiplet design has been one of those techniques that we've used to move quickly and to be disruptive and to change the dynamic in the industry. And people have asked me this before, why not? Why not chiplet for mobile? The difference is, with any of those design and architecture choices, there's a penalty. And if you think about chiplet, the penalty is when you slice the die into different components, you now have to move data back and forth between wherever that boundary is that you slice the chip, right? And that moving data back and forth ultimately means you're burning power. And so the challenge with chiplet in a mobile design is doing that in a way where the partitioning of the design makes sense to really get the benefit of chiplet scaling, but also doing it in a way where you don't pay an unnecessary power penalty for going from a monolithic design to a chiplet-based design. So again, kind of like the conversation we had earlier about graphics architecture, this is one of those fundamental architectural decisions that we debated extensively as we thought about planning, this generation of Ryzen mobile products. We looked at both approaches. We looked at chiplet, we looked at monolithic designs. And when you factor in, what it does for power and also what it does for the packaging of those chiplets into a notebook processor, a monolithic design was certainly the right choice for this generation. I'll touch on that last one just a little bit, because packaging in a notebook is also a critical part of enabling form factors. Most people, if you take your notebook apart, unlike a desktop which has a very large form factor motherboard, your notebook motherboard is a tiny sliver that runs across the top of your notebook underneath the upper portion of the keyboard with the battery that sits down below it typically. And even very small changes in X or Y dimension of the package that we put our mobile silicon into drive very significant design complications for OEMs trying to build aggressive form factor notebooks around our chip. And so the other kind of unbreakable rule of notebook products is stretching in the X or Y dimension unnecessarily really limits our ability to drive great notebook form factors. And that's a rule that we did not want to break with this generation of Ryzen mobile products.
So do you think that chiplets and that sort of design will ever be feasible? Or is it sort of for mobile, it just doesn't really make sense and monolithic really is the way that's going to make sense?
I have learned never say never is the right way to approach this, because the reality is technology changes, new innovations come into the manufacturing process that maybe overcome some of those hurdles. And I think that we will evaluate this with every generation of products that we plan, and go through those same trade-off considerations to understand what does it do to form factor, what does it do to power, and ultimately how does it benefit an end user who might buy this system.
Okay, I've got one final question for you. When we saw the Ryzen 2000 APUs launch, the first generation for Ryzen in mobile, I think fair to say that the driver situation was probably not as optimized and polished as it could have been, and there were certainly a fair few issues, particularly with the graphics side of things. What have you sort of learned over the last 2 years in terms of getting that software stack really polished, and are you expecting that everything's going to go smoothly? I'm sure you're expecting it, but what have you sort of learned to make that process a lot better for this generation?
That's also a very good question. I think that our journey over the past 2 years in mobile has taught us an enormous amount about how to build quality notebook products. That's both things that we've learned ourselves, and that's things that we've learned by working with partners on some of the premium systems that they take to market. For instance, the opportunity to work on a Surface Laptop 3 with Microsoft, the amount of learning that we gained from that in really driving more robust processes around our own internal validation and qualification simply helps us build better products for everybody. And I know some of the things that we talked about today are the fact that we've now evolved our quality process to a point where it involves continuous validation labs. We have farms of systems set up here in Austin, in Shanghai as well, where we're running both development systems as well as systems deployed in market with the latest driver updates, the latest patches, the latest OS releases, so that we're always understanding where do the problems lie, how do we get ahead of it, how do we fix it before it shows up in somebody's hands. And that's always our goal, is to fix those problems before it shows up in an end user's hands and catch that within our own validation processes. So I think we've made enormous strides from where we were a couple of years ago, bringing the first generation of Ryzen Mobile into the market. The quality of our software stack and the robustness of the processes around making sure that as we introduce new products, that same level of quality exists as those parts start to go into the world.
Yeah, it's good to hear. I think it should be much more stable experience for people buying it. And so thank you very much, David, for spending so much time with us and going through all the questions that we had lingering after, what's it been, 5 or 6 hours of in-depth sessions. It's been very, very interesting, and we'll have more Ryzen Mobile content up on Hardware Unboxed throughout the week. I'm sure there'll be lots of testing to be done as always and more stuff to get through. So stay tuned for that, subscribe for all of that good stuff. And we'll catch you in the next one.